If you like these videos, thumbs up. If you don't, it's okay. Thumbs down. Love your comments. If you haven't subscribed, absolutely appreciate that. Let's get into to doing. Let's do a cam one with a little bit of modeling. So this one here is from Visual. I would like to ask you specifically about machining thin-walled parts using Fusion 360 and specific option within Fusion 360 to help in machining such parts, and an option such as feed optimization to reduce chatter and load while turning sharp corners. I think this is a good one if you're into cam. And there's a lot of different ways to deal with thin machining parts inside of cam. But I wanted to share a tip that I have used that maybe would be somewhat useful. So let me just show you here. And again, there's a lot of different ways to do things. I'm going to start out by creating a line going up here. And I'm going to draw something up that is similar to what I have dealt with before. So let's just draw something up that looks like this. And now where we're using the mirror command, let's mirror this over this like this. Press pull. Draw a couple of parts like this. And let's just give it a base. S key. Send a rectangle like this Q. All right, so there's a lot of different ways to deal with machining thin parts. And if you're not into cam, this might look a little like, what are you talking about? But what happens is that when you start machining thin-walled parts, like when you start roughing this part out, you start getting a lot of chatter. Things will start breaking up and do different things. One trick that I have done, and then this maybe, I don't see your part visual, so maybe I'm a little bit off. But one thing that I have had a pretty good experience with in the past, a couple of different tricks. One have actually been to create my own little wall. So if you go in here and you do something like this, draw this one up. So I would actually machine a part like this, but this little wall here, I would maybe actually probably make it a little thicker. Maybe. Will reduce this chatter, at least for the beginning. Maybe now it's too fat. So that's one thing. So you could machine this and then machine it off. And there's a lot of different tricks to do this, but what I'm pretty much saying is you machine this shape up here, and then you could come in and just remove this center wall. And you might do that by kind of like step down, step down, step down. So, and I'm going to show you just in a second how to do that. But think about that, where you machine this whole top. You don't have a problem with thin walls and vibration, maybe. And then in the end, you come in here and you kind of like start stepping away this wall step by step, so you don't have any chatter. And then when you get down to an area where you start seeing chatter, because at some point you will have removed enough material so you start seeing chatter by stepping this away. Another trick is, and there's a lot of different ways you can do this, but another trick is to take a cardboard box and cut the bottom away and place that around it, and then go to Home Depot and buy some like installation foam. And again, I don't know how big your part is, but if you go and buy, like, this is not quite what I was looking for. I don't know why I wrote demo. Foam spray can. Yeah. Go and buy something like this stuff here that is used $6 here. So what you do is, you take your part. When you get to the point where you start seeing chatter, you take you take a cardboard box, it kind of fits over the part. You cut the bottom out, you stick that over, you spray this stuff around it, and then you machine the areas out where your chatter is, and that will hold the part in, and then in the end you just kind of like scraping it off. Okay, so that was kind of part of, maybe this is useful, maybe it's not, I'm just wasting my time. But if we go in here to the manufacturing, let's throw some toolpath on this. And you actually specifically said using the 3D pocketing clearing toolpath. I would probably not use that at this point. I would actually probably use adaptive clearing, but it's not going to change much except we will get some more interest. So let's just select this. I'm going to select your 3D pocketing because that's another tutorial, right? Let's select a 5mm cutter just because I don't know how big I machined this. Let's just go in here and look at this cutter. So we got a 10mm flute length on it because I know that I'm going to have collisions in here. If we go to the bottom here and we select from the start top minus 10mm because that's the depth we have. Okay, so we get this. Edit this toolpath again. See what I did there? I don't do all kinds of tweaks. I kind of just do one thing and then I'll go back and look at it again. Let's do a 10mm step down. Hit OK. So now we're only getting this 2 passes. Edit this again. Let's go in and turn flat detection area off. So now it's not going to do the top. Now it's only doing one toolpath 10mm down. This is probably not the toolpath again I would select, but it shows what I'm trying to get at. So now you see that I'm machining this around here. Now what one of the other things that Visual pointed out was the fact of using feed optimization for, because I don't know how his part looks like, for corners. So let's go in and right click edit, and if we go back to the passes tab, there is feed optimization in here. And maybe this should be another video where we can talk about tolerances and smoothing, and send me an email and maybe that can come in here. But there's a feed optimization in here, and with this turned on, I'm gonna hit OK. When you turn that on, you will actually see that on this toolpath in here, we get a little notification in here. And what is happening is that when it gets to that corner, it will turn down the feed of the end mill to assure that it just hammers in the corner. So that's what feed optimization does in here. So what it does, just to run through it quick, maximum feed directional change. So if there is a change more than 25 degrees, it will turn feed optimization on, and a reduced feed radius of this reduced feed radius, specify the minimum radius allowed before the feed will, so you can control and play around with this, but you can control when this kicks in, the reduced feed distance. So that is how long before it comes to this corner is it going to start slowing down. And this could depend on your machine, and then of course how much you want to reduce the feed width. And then there is a only in inner corners or outer corners, again depending on where you are setting these things. So that can be a good way to slow down these corners. So it's a maximum direction change. So if it was running down and it only saw a 10-degree change going, it's not going to do it. But if it sees a 30, then it will. Then there's also a reduced feed radius. So if it's looking for radiuses, when should it do it? How far before it gets to that reduction should it start doing that? So maybe 1 millimeters. If you have an older machine, then maybe it takes a little bit more time to adjust. We might go, to 5, and then where you want it to go down. So that is definitely a very good option to turn on. See, the changes now became a little bit longer when you are doing that. Now, I want to kind of just show you with my example here, now we have done this. So what you could do to machine, because we really don't want this wall in here, if this is good, if we're happy with what we got here, of course, you will have longer tools, you'll machine deeper down. Right click and you can protect this toolpath. What means that is now locked. Check this out. If we go back into the design, and what if we delete that wall I created? So now we go back here. Go back into the manufacturing tab. Now because I locked this, we're not going to get any flags. This toolpath is still pretending that there is a wall. We can do a right click and we can do a copy. Right click up on the setup and do a paste. So now we're kind of selecting that same toolpath again. They're the same, but check this out. Let's right click on the second toolpath and turn the protection off. Now as soon as I do that, we get a red warning because it knows that that wall is gone. What we could do is go right click, edit, go into your geometry tab, turn on rest machining, and say from previous operation. Hit OK. And now this toolpath is only going to do everything to remove that wall. So if we went in and we simulate the first two, let's go ahead and simulate this. And this is not going to be right. I know this is just me hammering away here. But if you turn the stock on, let's turn the toolpath off for a second. And we machine to the first toolpath. We have this, right? So I machine that down. Now we want to get rid of the wall. It's going to just come in here and it's going to machine the wall away. Now, of course, again, you would have to do different things with step downs and things like that. But if you did this almost like step down, step down, step down, step down, then you might be happy with your result. Hope this was useful. If not, thumbs down. If it is, and if you haven't already, I appreciate it if you do that. Subscribe.